All right, so we have, my notes. We have Joe and John will be talking today about OpenHTF, yes. So I will hand it over and let them take it away.
Okay, hi guys. I'm Joe. My colleague John is on the way. Hopefully his parts don't really start till the second slide or so maybe we'll make it. So I'm one of the current maintainers of OpenHTF. John is one of the authors of the original internal testing framework that OpenHTF sort of evolved from. OpenHTF is one of the libraries we use at Google to facilitate hardware testing. In addition to talking about OpenHTF, I want to touch a little bit on general approaches to hardware testing at Google, how that kind of shaped OpenHTF, and also want to mention, as the name suggests, OpenHTF is open source software. The URL is up there, github.com/Google/OpenHTF, so you can go check it out. If you do that, we have, at the top level of our repo, we have an examples directory. I recommend starting there. In particular, there's a script in there called hello-world.py. Check that out. There's a lot of inline documentation that shows you what's going on. That's kind of the basic example of a test script that you would create with OpenHTF. Okay, so the needs motivating OpenHTF sound pretty similar to the needs that would motivate any other framework that you might use for hardware testing. So you want to exercise a piece of hardware, you have, whether it's like a phone or a head-mounted display or some other device, consumer electronics or part of some bigger assembly like a server or a piece of networking gear. You want to exercise that hardware, you want to take some measurements, you want to record those measurements into a log or a record as you go. And then at the end, you want to do something useful with that record, like save it to a file on disk, upload it to a server somewhere, something like that. And the whole point of using a testing framework to do this is to make life easier for the folks authoring tests. So in our case, that's mostly hardware test engineers. But I think I want to dig into that a little bit because I think it's subtle but important. A lot of the pre-existing tools at Google were kind of oriented towards a more software engineering heavy audience, even though they were ostensibly catering to hardware testing. But we wanted explicitly to make something that we could use to partner with contract manufacturers, vendors, hardware engineers and hardware test engineers, and that would give these folks all an easy interface to focus on the parts they care about, which is test logic. Okay. So consider that for a long time, Google had built itself as a software company, and kind of still does in many ways too. One notable exception being the platforms team at Google, which is the team that designs the like data center infrastructure, servers and networking gear. But now, of course, things have changed. We do a lot more hardware. There's a couple examples up there. We have Glass, Daydream, we have self-driving cars, all sorts of different consumer hardware with the newly formed consumer hardware group. And so with all these new types of hardware testing, we found that all these different teams started forming their own tools. And they were all catering to different purposes. And we really wanted something that would be general enough to capture most of the use cases. So OpenHTF came out of a team that included both hardware engineers, hardware test engineers, and software engineers all working closely together. It was written and rewritten with non-software engineers in mind as the primary consumers. Specifically, we wanted to make something that would cater to hardware test engineers, electrical engineers, contract manufacturers, and vendors. And then over the course of a few iterations, it became more lightweight, more focused, and platform agnostic. Welcome.
Sorry, running a little late. Missed the introduction. I'm John Hawley. I was a member of the team that wrote the initial version of OpenHTF before it was open source and all that. So I still sort of co-maintain with Joe and run late to meetings. Yeah, so I can give a little bit more context for some of the sort of original motivation behind some of the decisions that were made. I'll let Joe continue.
Cool. Main takeaway here is proliferation of hardware projects at Google. OpenHTF came specifically out of the Glass team, and it came out of a team that was that had software engineers and hardware test engineers working together, which allowed us to create something that looks a little bit different than some of the other test frameworks available. And
notably, the need at the time was actually driven primarily by manufacturing. We were doing manufacturing locally in the States, and we're trying to be pretty scrappy about it and doing a lot of things ourselves. There weren't really any internal test frameworks that ported well to the manufacturing floor.
Okay, so the solution we came up with is a Python library. We chose Python because most of our hardware test engineers write Python scripts already to do things like kickoff tests, analyze data, et cetera. And we made it a library because we wanted it to be a straightforward import, just like any of the other tools that are commonly already used in hardware testing, like NumPy, Pandas, Matplotlib, and things that hardware testing folks are already using in their day-to-day work. And like most Python libraries, it's pip installable. So if you have an internet connection, you can just pip install OpenHTF and start using it. Also, as a library, it makes it easy to integrate with other frameworks in terms of deployment, scheduling, and things like that. We don't really provide solutions for those things out of the box. We're focused just on the hardware test authoring interface. So with your test script being just a straight Python script that imports our framework, you can do all sorts of things with it. Embed it in other frameworks, use it in any scheduling system you want, deploy it any way you want to deploy it.
Yeah, so a little bit more about that decision. Originally, obviously, if we're just running our own manufacturing floor, we did have a full execution environment. It was the only thread that was running. We controlled everything about what was going on, including deployment to the machine, scheduling, all this kind of stuff. We can talk about that a little more later. But when we decided to open source the code, we decided to make it more of a library because that integrates a lot better with what other people are doing, right? We don't really want to have to take over and say, okay, this is, you have to sub-process call to invoke this or something like that, right? So this was actually a lot of work. In fact, Joe did a lot of the work on sort of tearing out some of the process-specific stuff and making it actually work as a library. So hopefully, we're hoping that this actually makes it a lot easier for other people to make use of it.
Mm-hmm. Okay, so I kind of mentioned our...
Oh, yeah, that's right. So I already talked about this a little bit. The manufacturing floor is sort of the original use case. Some of the constraints there that were really driving us were that we had operators using the stations, not test engineers, which is pretty common internally. You usually have like test engineers overseeing things. But we did have test engineers writing tests, so not software engineers. So we didn't want to go too complex. It was kind of a sweet spot that we really needed to hit there. In an automated lab, we typically have test engineers writing the tests and running them. So they'll usually actually be a little more comfortable with command line interfaces and things like that. Sorry, I forgot to mention manufacturing floor. To that end, we actually have an HTML-based graphical front end. So you don't have to use fully command line tests. The automated lab, typically you'll have more of a command line interface. You'll have jobs getting kicked off automatically by something, and you'll be outputting to some sort of data store or something like that that varies sort of by use. Benchtop is a little bit more, you have engineers writing tests, right? And that's when the code gets really bad. But yeah, that's usually something you wouldn't have too tight control. You don't typically have like version control over your tests even. It's just like I built some hardware, I need to test it or something. The last one, we don't really expect OpenHTF to have a huge value add. You could just as easily write a little Python script that talks over a TTY and does your thing. But if you get used to using it or something, you could design an output module that outputs into a format that you like or something like that, and then get some code reusability there.
So the main abstractions of OpenHTF, the top level thing that we care about is a test. We have a class called test, openhtf.test. What you do is you instantiate a test object, and then you execute it by calling its execute method. Those tests are broken down into phases, which are kind of similar to test cases. Phases can be as simple as just a Python function. They're kind of the atomic unit of testing. And then within phases, you set measurements, which are exactly what they sound like, individual pieces of data collected during the course of the test. Sometimes you want to save an artifact like a JPEG or a WAV file or something that was generated during the test, and we have an abstraction called attachments to do that. Finally, we have something called plugs, which are the interfaces to hardware, and we'll talk in a little bit more detail about plugs in a little bit. And then output callbacks let you do something useful with the test results once the test run is complete, like save it to disk or upload to a server.
So notably here, the pieces that are up to the test author to implement are typically just the phases. Normally, you would have also some test engineers that are a little more comfortable with Python, writing things like output callbacks if you're outputting to some local data store, or you could even have upload via HTTP, HTTPS, whatever. And then plugs are interfaces to various hardware. We have a small set of base plugs. We'll talk a little bit more about them later, but typically you'd end up having an engineer also have to write a Python interface to whatever hardware it is you're talking to. A lot of things come with Python interfaces already, though.
Okay, so wall of text, I know. So this is kind of a distilled example of an OpenHTF test script. So aside from the fact that widget plugs is a fake module that I made up for this, this test would actually run. This is pretty much all you need in order to create and run an OpenHTF test. Main stuff here to look at is you import a bunch of stuff at the top. You define some phases. Phases are functions. The first one's a very simple one. The second one is a little more complicated. You can decorate those phases to declare what their inputs and outputs will be. And then finally, at the very last line of the text, you'd call test.execute to run the test. And that call to test.execute blocks until the test is complete and the output module is run.
Yeah, so the general approach here is we use decorators a lot in OpenHTF. It kind of makes it a little bit more declarative about what exactly you're going to be measuring in any given phase. The original motivation for this was we liked having, and we'll talk a little bit more about config later, but we actually have a key value mapping in a config file. It's a sort of a YAML file, and it lets you have some declarative stuff. But we found that putting a lot of declarative things there actually decouples it from the code a lot and makes it really hard to sort of visually track what's getting measured where and what's going on. So over the course of one of the iterations, we moved that to decorators, and now I actually really like how this turned out. We have pretty clear inputs and outputs, although here I guess they're in the other order, they're outputs then inputs, but they can go in any order, they're just decorators. And they're right next to the phase that's doing it. So it's still sort of on the test author to write, to split their test up into phases that sort of make sense. You could obviously just put all your outputs and all your inputs on one phase and have a 1,000-line Python file. I've seen plenty of those in hardware testing. But the hope is that this sort of enables you to break it up a little bit more sensibly and make it so that the next guy who comes and reads your test can say, okay, I understand exactly what these chunks are and what's going on.
So plugs. This is actually one area where we need some help from you guys, the testing community at large. So plugs are what OpenHTF uses to interface with hardware. We call them plugs because plugins we felt was too indicative of pure software extensions, and we liked how the term plugs called to mind physical hardware. Our desire is to have a large collection of these plugs available to interact with like tons of different off-the-shelf test equipment. So anything from power supplies to oscopes to logic analyzers to sensors, whatever you might use in a test fixture when you're testing a piece of hardware. Right now, our collection is pretty thin. We have some Android-related stuff. We have an ADB plug, and we have some generic USB stuff in there. But mainly, we've been focused on writing the framework itself. And also, a lot of the plugs we use internally are wrapping proprietary internal hardware or otherwise not things that we can share. But we do want to increase the collection of plugs that we have to share. So calling on you guys to make contributions to our GitHub repo. And when you write plugs to wrap your test equipment, please consider contributing them back to us.
Yeah, so this has evolved a lot, actually, over the course of this is probably the single thing that's changed the most number of times in the many iterations of the project. I kind of like the plug thing that we've settled on. I think it's pretty good. We're sort of centering it around building from the bottom up, right? So we have plugs that support, USB, serial, some low-level interfaces like that. More complex fixtures that may have a few serial ports. We have a couple one-off instances of those. We're still working out sort of exactly what the best way to use plugs together and how they play nice like that. But we are slowly building up a library of useful plugs. And also, I mean, it's a pretty small wrapper. Basically, you have to inherit from baseplug for internal sanity checking purposes. But a lot of pieces of hardware will actually have a Python library ready to talk to them. So this ends up typically being a pretty thin layer.
This is one more thing we want to show you before we open it up for questions, and that's the web GUI. So knowing that we were going to deploy this to things like places like a manufacturing floor where we're going to have operators interacting with it that aren't necessarily familiar with the command line interface or the test script itself, we wanted to provide an off-the-shelf user-oriented experience. So when you run these tests in a separate terminal from where your tests are running, you can invoke this web GUI as a runnable module with Python-M. That starts up a web server that will automatically discover any OpenHTF test that's running on local machines on your local network, and will give you a visual representation of them with color-coded test phases and measurements. And it updates in real time so you can follow the test as it goes along. In this one, I have a test with the ID of foobar-baz, and then there's a couple of phases, and I've expanded the hello world phase so you can see the measurements inside the phase.
Yeah, so kudos to Joe on this, actually. The internal version had a sort of Google internal front end and all that, and was not portable at all. So he actually completely rewrote the front end aspect of the project to open source it. It does do some really neat stuff around, like discovery is just multicast-based discovery for local network. These are things that actually come in real handy on a manufacturing floor when you've got a lot of testers out there, and manually managing a config file of what all their IP addresses are gets to be a lot of overhead, actually. Yeah, this is a pretty awesome thing. This is still sort of evolving a little bit. We make minor tweaks to it all the time, and get a lot of internal requests. We should probably start forwarding people more to the external mailing list so there's more visibility. But yeah, this is still growing a lot. So there's definitely feature requests are welcome and encouraged around this.
Yeah. So the test authoring API, like that wall of text slide we showed, is all pretty solid and shouldn't change too much. The web GUI is still being tweaked a little bit, and we want to add more plugs, and we're still figuring out some of the nuances around plugs too. The main test authoring API should be pretty stable.
I hope so. It's changed, I think, like 4 times now.
Yeah. I think we got the good version this time.
In about as many years, yeah.
Okay, so that's kind of all we had prepped. So let's open up the floor for questions.
Yes, thank you, Joe and John. And to be fair, by Google and California standards, John was not actually late.
Right?
Within
Especially
the margin
engineer standards.
of error.
I'm early for the next meeting.
Can this be used to test mobile devices' battery consumption during an application over a period?
You want to talk about monitors, maybe? That sounds like a good application of monitors.
Yeah, sure. So we have a little bit of an addition to measurements that we call monitors, and we found it's something that comes up a lot actually, where you just sort of periodically want to check something and store those values in some sort of list or something. And so there is a mechanism, yes, monitors, that will allow you to basically say, tell the framework how to take the measurement, and then it will just periodically do that. So you just, once you write the code to talk to the device and grab the battery level, then yeah, it's pretty easy after that.
Yeah, and it keeps running through the entirety of the test, right? Not just the
monitors
phase?
are currently just the phase. We're actually talking about making a mechanism for doing so over the course of a test, yeah.
Okay.
My question is, have you had any exposure to National Instruments LabVIEW product? Have you seen how they do it? And was that part of the evolution to where you got?
Yeah, LabVIEW, I have unfortunately been personally tasked with porting a handful of drivers, I guess you might call them, for LabVIEW over to OpenHTF. Yeah, LabVIEW is an interesting way of sort of making hardware or software play nice, right? It's people who don't have a lot of software experience write tests, really, is sort of the target there. I found that it starts to blow up real fast when you get to big tests, though. You get the lines everywhere and lots of stuff to follow. So there's a place for each of them, right? I think they can definitely coexist. LabVIEW is great for like spinning up quick little things. Unfortunately, we don't really have any sort of way to automatically use LabVIEW drivers, which would be awesome. There's a lot of National Instruments test equipment out there, yeah. But we are working on it.
Yeah, we kind of wanted to be agnostic as to which test equipment you were able to use too. So didn't want to like bias you towards National Instruments stuff or whatever. Or when I say you, what I really mean is our audience of hardware test engineers at Google who use these tools. Wanted to let them go to whatever vendors they want, get whatever test equipment they want.
Yeah, really, there's nothing precluding you from running an OpenHTF in test within LabVIEW, actually. You could write a block that would run an OpenHTF test, right? Which is sort of the neat part about removing the execution framework from OpenHTF. It lets you do stuff like that.
Good. Are there any plans to support gaming consoles, PS4, Xbox One, etc.?
That's an interesting one. I actually don't know what that would involve. I'm sure somebody out there got really bored and wrote a Python interpreter to run on these things. So you probably could, yeah. The other approach would actually be to run the actual Python test off device, which typically is more what you see for mobile things. You want to run the test off the device because if the device dies, you don't get any logs. And then you just really need a way to talk to it, which I personally don't know much about the hardware testing of these platforms, but I would assume there's a TTY header inside or something like that for testing purposes.
Yeah, so I guess there's kind of two questions inside that. One was, can we execute OpenHTF tests on those platforms?
Yeah.
And the other is, can we use OpenHTF to test those? Kind of different answers, but if someone wants to write plugs to wrap those for testing those devices, that would be awesome.
I'd like to commend you on your use of different interfaces for different personas, different end users for the tool. I wondered how much you'd done in the way of usability or user experience design in designing those interfaces. What process you'd gone through for that?
Yeah, so internally we did have a UX designer sort of consult with us. He didn't necessarily design the whole front end per se. It was kind of, we were borrowing some of his cycles. So we haven't had dedicated UX resources on it, but we did have, we have had input from the one UX guy who was helping out. And we do actually have a couple teams are actually using the web GUI, right? I think
yeah, a couple
internally.
Mm-hmm.
Yeah, so we do have a fair number of users out there that have given feedback. So this was I think the third iteration of the web GUI.
Yeah.
Yeah, so we have gone through a couple iterations and had some rounds of like user feedback and things like that, and some pretty big features. History actually on there was a lot of work to do because we weren't internally tracking previous runs of tests, but it turns out for the web GUI experience to really work right, you kind of need to be able to see the last couple that ran. So we actually put a lot of effort into adding that in. So we've gone through a couple iterations of sort of user feedback, yeah.
But we're definitely open to more feedback too. So if you have,
Yeah, like I said, that particular part is evolving still a lot.
yeah, submit pull requests to us or just even file issues with your suggestions, and we'll definitely take a look.
Good. Can you give a concrete example where your framework was used and how it improved over earlier versions, if any?
This one, I'm happy to say we actually don't have enough time to go through all the examples of this. Originally on Glass, we had our contract manufacturer writing manufacturing tests, and this was very, very early on. They had many hundreds of lines of script files of their proprietary internal language that for some reason they made up because there aren't enough languages out there. So that was actually the formation of the team that created the original framework. I was asked as a software engineer to come in and help out, and I looked at it and I was like, oh my God, what's going on? I was actually given a couple people to work with, and we came up with a framework and had, I guess the most quantifiable improvement there is turnaround time on fixes. It used to take them at least and this is, keep in mind, local, take them at least 2 weeks to fix any issue, no matter how small. By implementing it ourselves and doing it in Python, we had turnaround times of roughly less than 24 hours on issues. It was a really big improvement. I'm trying to think, I'm sure there's plenty of other.
Yeah, I think the self-driving cars is another another good example of where they had a bunch of different disparate internal tools and cobbled together scripts and stuff, maybe some LabVIEW thrown in the mix too even, and they've started moving stuff and standardizing on OpenHTF. So I think the main benefit they're getting from that is having the consistent output format for everything. So every test outputs a record that's in a consistent format. You can upload it to the same data system.
Mm-hmm. Yeah, the history of that, the two teams actually used to live really close together in X, Glass and Chauffeur, and so they saw what we were doing. We're like, hey, let's do that, and we're actually getting a lot of value add from it. So much so that they actually grabbed one of the guys from the Glass team who used to work on OpenHTF, or the internal version of OpenHTF, and he's now over there, helping them out. So it is spreading a lot. Internally within Google, there are actually quite a few teams using it.
All right, and I think we have time for one more. How does the framework communicate with the device? What are the requirements of the API that the framework drives?
Yeah, so plugs are very open-ended in that sense. So most of the plugs that we use internally tend to be wrapping, like a thin wrapper around some third-party or vendor code that either comes with the device or is some third-party library that already exists within Python for doing the hardware communications. And then the plug is the layer of abstraction you put around that interface to just pull out the functionality you want and make it easy for test flow to look clean and
Yeah, we've spent a lot of time, especially in previous versions, actually trying to get this to be a nice, clean interface and be uniform across all different types of hardware that you want to talk to. It turns out the hardware world is an absolute mess when it comes to interfacing with it and how you talk to things. If you're writing low-level board-level tests, you've got I2C you probably want to talk, serial. I actually ported a VXI11 driver over. I don't know how many of you have ever seen or heard of that. There are a lot of things out there. So. The idea is by having just a base class that you have to subclass, it kind of leaves it pretty open-ended. That's basically the only constraint. So I guess the second half here is what are the requirements of the API that the framework drives. There are no real requirements except that you subclass that base class. And that's mostly for sanity checking purposes so you don't accidentally do crazy things. Otherwise, it's if you can write it in Python, you can make it work.
Yeah.
And that may even actually mean writing a Python extension in C, which I have also had to do to get, because a vendor had a C library but not a Python library. So
you can even shell out to binaries. And
you can do some pretty ugly things. I don't really want to admit to having done some of them, but you kind of do what you need to do.
Great. Well, yeah, thank you, Joe and John.
All right.
Thanks, guys.
Thank you.